Okay. Inshallah, we'll start now, part 3. Do more problems. Now, this is Gauss integer function. I want to get this limit. Notice if we substitute, we get an integer, so we can do it quickly. That will be Gauss integer 1 minus 3/2, which is Gauss integer minus half, which is minus 1. We know if this is a non-integer, just we can substitute. Now we'll move to problems related to squeeze theorem or sandwich theorem. Notice here I have sine pi over x is always between -1 and 1. E to the power sine pi over x is increasing function, so that will not affect the inequality. Square root of x, since x goes to 0 from right, square root of x is always positive. Square root of x is -1. X goes to 0 from right. This goes to 0. This goes to 0. It means this one goes to 0 by the squeeze theorem. So the answer is 0. Here, we'll do the same thing. As x goes to 2, this goes to what? 4 minus 1, 3. And this one goes to 3/2 times 2, which is 3, plus sine 2 pi, which is 3. So this one goes to 3 by the sandwich theorem. By squeeze theorem or sandwich. Same thing. I think this is very clear. Cosine 1 over x minus 1 and 1 multiplied by x squared. As x goes to 0, this goes to 0, this goes to 0, this goes to 0. By sandwich theorem. Same idea. Sine pi over x minus 1 and 1 multiplied by this square root. This will be square root minus sine. As x goes to 0, this goes to 0, this goes to 0, so this goes to 0 by sandwich theorem. Note is if x is 0 plus or 0 minus, always this will be positive. So I have no problem with that. So this is equal to 0. Same idea. X goes to 3. This will be 8. This will be 8. So this one will be 8. Same thing. Sine 1 over x minus 1 and 1. X squared. 2 minus x squared and x squared. X goes to 0, this goes to 0, this goes to 0, so this goes to 0 by sandwich theorem. Okay. Now we need to find the limit of this, but we notice the limit as goes to 0 from right for f of x is what? Is my from right, I'm here, so it will be -5. But limit x goes to 0 from left. I'm here, so it will be -1. So the limit of f of x, as for f of x when it goes to 0, does not exist. This is g of x. I want to check the limit. X goes 0 from right for g of x. From right, I'm here, so this is -2. This goes to 0 from left. Less than 0, so you are here. So it will be 2. So it means the limit of g of x, as this goes to 0, Does not exist. Now, does not exist minus does not exist, it doesn't mean it does not exist. So what I will do, since the limit from the right for both these two functions exist, I can do the limit. To do this limit, I'll do it from right and left. X goes to 0 from right, the f minus g. From right, both limit exists, so I can distribute the limit. So that will be f from right minus 5 minus 2, and that is minus 3. And limit x goes to 0 from left. We'll do the same now from left. F from left is minus 1, and g from left is 2. Oh, both are the same, so this limit equals minus 3. This is, yeah, this is depends on this formula. If you do a plus b square minus a minus b square, you get what? A square plus 2ab plus b square minus a square plus 2ab minus b square. So it's 4ab. And a times b is this one. Why I need this? Because we'll apply it where a is yeah, a is f of x and b g of x, and we'll take the limit. We'll take a f of x and b g of x, and I will deal with the limit. So that means the limit as this goes to 0 of ab, اللي هو f of x times g of x, will be the limit as it goes to 0 of f of x plus g of x square minus, yeah, minus the limit, this goes to 0, f of x minus g of x. I can do it in 2 steps. Minus f of x minus g of x all square over 4. This is equal, this is equal. So now, this limit exists, the sum exists, also the difference exists. So the square for sure exists. And also we can distribute the limit. This the square exists, so we can distribute the limit. So that will be limit x goes to 0, f of x plus g of x square minus limit x goes to 0, f of x minus g of x all square over 4. Or the limit as goes to 0, 4, which is 4. F of x plus g of x, the limit is 2, so I have 2 square minus 1 square over 4, and that's 3 over 4, which is this. Now I want to deal with x goes to 1 from left. Let us do it in 2 steps. First, what is the limit as goes to 1 from left of f of 2x? Note, if x goes to 1 from left, that means 2x goes to 2 from left. So I need to check f of x as it goes to 2 from left. This is 2 from left. This is 0. This is 2. It's 2 from left, so I am here. So that will be 2. This limit equal 2. And what is the limit of g of x? It goes to 1 from left. For g of x goes to 1 from left, it will be also 2. So all of this limit, just I substitute x to the power 4, f of 2x plus 3g of x. This limiting this limiting this. As it goes 1 from left, so you can just substitute. It will be 1. This limit is what? I can distribute the limit, I mean. This is times 2 plus 3 times 2. So the answer is 8, which is this. A equal this limit and B equal this limit. What will be C, A minus B? Actually, I need to find A and B. If x goes to 0 from left, x goes to 0 from left, that means x plus 1 goes to 1 from left. That means this is goes to 1 from left, point something. So the limit, as if goes to 0 from left of this. This is goes to 0. The numerator goes to 0. 0 over a number, it will be 0. This is A. Okay. 0 from left. Oh, no. It's not x plus 1, it's x minus 1. Sorry for that. X minus 1, it will be minus 1 from left. It will be minus 1 from left. Okay. 0 from left, so you subtract 1, minus 1 from left, which is minus 1 point something. So this greatest integer x minus 1 will be equal to minus 2. So you have A, the limit as goes to 0 from left of this over x minus 1. So that will be minus 2 over minus 1, which is 2. Now, x goes to 0 from right. Now it will be x minus 1. We'll go to what? Minus 1 from right, which is minus point something, minus 0.999. So greatest integer of x minus 1 will be minus 1. Will be minus 1 from right. We subtract 1. 0 from right, 0.111. Subtract 1, still minus 1.99. It will be x goes to 0 from right. 0 from right, like 0.001, okay? X minus 1, 0.001 minus 1, let's see here, minus 0.999, something. Okay. Minus 99 plus this will give you, will give me my minus 1. This, okay. Yeah. Now, this is minus 1 from right, huh? Minus 1, this is minus 1 from right. So now what is the greatest integer of this? That will be minus 1. That will be minus 1. So what will be B, which is limit, x goes to 0 from right of this? It will be minus 1 over minus 1, which is 1. Now substitute. So B is 1 and A is 2. So that will be 2C minus 1, which is this answer. Okay. This limit equal 15. Notice the limit of the denominator equals 0. So that means for this limit to exist, the limit of the numerator should be equal to 0. Provided this limit exists, I have limit is goes to c, f of x minus c. This one, if you let x equal c, if you let t equal x minus c, so this limit will be what? Limit f of t as x goes to c, t goes to 0. So this is the same. So this one, provided this limit exists, so I can distribute the limit. The first one will be limit as t goes to 0, f of t. Okay. This is, you can always substitute, plus c minus 1 equals 0. So the limit f of t as t goes to 0 equal 1 minus c, which is this. Goes to infinity, or what? Yeah, we need to do squeeze theorem, and we can add the value to c. So we know that in sine x between minus 1 and 1, exponential will not affect it. Yeah, actually goes to infinity is not part of this, but it will be okay. 1 over x plus 2 e sine x is between 1 over e x plus 2 in a e over x plus 2. Add 2c, here 2c. As x goes to infinity, for sure this is goes to 0, so all of this goes to c, and this is goes to 2c, so the one in the middle goes to 2c by sandwich theorem, or by the squeeze